Next slide, please. And the capable know-how of the SWS staff. We're excited to roll out this new benefit for all SWS members. So even those members who cannot attend today in person will have access to the recorded webinars, and you can watch them on demand. And I believe those are going to be posted by tomorrow, right after the live webinar. So the general format of our webinars will be a 40 to 45-minute presentation by our speaker, followed by about approximately 15 minutes of questions from the participants. And also be aware that we will announce the next webinar at the end of the session, and we're generally following a monthly schedule. Next slide, please. So before we get started, I want to go over a few housekeeping announcements. Just to familiarize you with the go-to meeting screens, if you're not familiar with it already, there's an attendee control panel where you can control the audio for the webinar. And you can use audio either through your computer or your telephone, and you can consult the directions in the audio pane on how to do that, or also in the email that you received announcing the webinar. And at any time during the presentation, you can type questions that you want to ask to the speaker, and you use the questions pane to do that. And as the moderator during that question and answer time at the end of the presentation, I'm going to read the questions to the presenter so that everybody can hear the questions clearly. And also I want to note that all the attendee phone lines are on mute to cut out background noises and distractions. The webinar is being recorded, and you'll receive a link to that recording following the webinar. And we also ask that you take a moment to complete the evaluation survey that will pop up at the end of the webinar. And this will help us to plan future events. And if you're really tech savvy and you want to tweet about today's webinar, please use the hashtag SWSwebinar. So I want to test the questions pane and at the same time get a little demographic information about our participants. So if you would go to the questions pane and type the state or country that you are calling from or participating from, and how many people are viewing the webinar with you. So we'll take a couple of seconds to watch those states and countries roll in. I trust that we have some folks from, let's see, we have some people from New Jersey. I know I'm calling from Florida. Our presenter today is from Maryland. And we have the SWS staff that's in Wisconsin. We have people all the way out in California and the Netherlands. So we have people from all over, and that will help us to gauge how many people and participants we have today and what the geographic scope of our webinar is today. So with the logistics out of the way, let's get started with our webinar. Next slide, please. It's my pleasure to welcome today's presenter, Dr. Ariana Sutton-Greer. She's an ecosystem ecologist with expertise in wetland ecology and restoration, biodiversity, biogeochemistry, climate change, and ecosystem services. Dr. Sutton-Greer is a research faculty member at the University of Maryland and the Earth System Science Interdisciplinary Center, and also the Ecosystem Science Advisor for the National Ocean Service at NOAA. She holds bachelor's degrees from Oregon State University in both environmental science and international studies, and a doctorate degree from Duke University in ecology. She leads the NOAA Coastal Blue Carbon Team, as well as the Interagency Blue Carbon Group. And she gets especially excited about seeking and discovering innovative opportunities to combine science and policy to solve environmental problems and promote ecosystem conservation. Her research has been published in many environmental policy journals and featured in several news stories, as well as apparently a children's science TV show. Many of you may recognize her from the annual meeting in Providence, Rhode Island, where she served as a panelist on our climate change and wetlands workshop. So with that, I would like to hand over the presentation to our presenter today, Dr. Ariana Sutton-Greer.
Great, thank you, Kim. I really appreciate the opportunity to give this inaugural webinar. And I just want to make sure I have control of the slides here. Yep, looks like it. Great. So thank you, everyone, for joining today. And I wanted to just start with a really brief explanation of my sort of unique position, where I am research faculty at the University of Maryland, but I also actually at the National Ocean Service at NOAA. And this really gives me the opportunity to both do scientific and policy research, but with direct connections to federal policy and to the federal policy world, or at least with specific policy context in mind. And so I'm very excited to have the opportunity to give this particular seminar today. And Michelle, I thought the slide advanced when I clicked before, but now, okay, there it goes. Never mind, we're good now. Okay, so policy opportunities come in many shapes and sizes. This is one of the things I've come to learn while being at NOAA. And one of the things I love to do is to figure out where there are innovative policy opportunities that can lead to conservation outcomes. And this can be via new regulations or policies that are coming into effect, or via changes in the implementation of existing policies. I'm going to talk about a mix of both of these today. But if I had only 30 seconds to discuss policy opportunities for wetland conservation with all of you, what I would say is it's important to think about leveraging all the different benefits of coastal ecosystems. And then to figure out where a particular benefit or suite of benefits will fit into an emerging or existing policy. And so this might be habitat for key species, or recreation, or storm protection. So you figure out which one of those benefits to leverage and to try to incorporate into the policy setting. And one of my favorites is the carbon sequestration and storage benefits of wetlands, or coastal blue carbon, which we'll be talking about more today. So today I'm going to really give you 3 examples of the type of research I'm doing related to understanding and leveraging specific benefits of wetlands in order to find policy opportunities for wetland conservation, either protection or restoration. So we're going to start with coastal blue carbon, then we're going to move to green or natural infrastructure, and last I'll cover some of my work on the nature, biodiversity, and human health relationship. So jumping right in with blue carbon, let's get started by making sure everybody knows what I mean when I say coastal blue carbon. So green carbon is the carbon taken up and stored in terrestrial plants. We often think of forests when we think of green carbon, although other ecosystems also store carbon. Black carbon is the carbon that's emitted through either the production or use of fossil fuels and also the burning of natural ecosystems. So then blue carbon is the carbon taken up and stored by coasts and oceans. And the work that I've been doing the last several years really focuses on just the component of that that's the coastal blue carbon. So this is the carbon taken up and stored in coastal habitats. Primarily we think about salt marshes, mangroves, and seagrasses. And as you'll see on this map here, we have seagrasses in green, salt marsh in yellow, and mangroves in orange. What's really neat about these 3 ecosystems is that almost every coast around the world has at least one, if not more than one, of these ecosystems present. So really, coastal blue carbon is almost everywhere, at least particularly in the places where humans are living. And so why are we suddenly so interested in this? Well, so more recently, in putting the science into perspective, we have recognized that coastal habitats are really impressive natural carbon sinks. So what you're seeing here in this graph is 3 different kinds of forests on the left-hand side, and then the 3 coastal ecosystems I mentioned on the right. And on the y-axis is the carbon burial rate in soils. And I want you to note the log axis there, which basically means that the 3 coastal ecosystems are burying carbon at rates that are greater than 10 times as much as those forested systems. And so what this means is that even though these coastal ecosystems really are just that fringe margin around many of our continents, so they're a much smaller total area, they have, because of these greater sequestration rates, they actually represent an approximately equivalent annual sink to those forested ecosystems. So consider that to be the carbon that was annually going into the ecosystems. It's sort of like your annual. So then the next question is, well, what's already in your bank account? That's what we're seeing here in this slide, is the fact that coastal habitats not only sequester carbon at high rates, they store large amounts of carbon. So what you're seeing here in this graph, again, those coastal ecosystems are in the top 4 bars, and then it's compared to a tropical forest on the bottom bar. The green part of the bar is the carbon stored in living biomass. And the brown part of the bar, or the tan color, is the carbon that's stored in the soil organic carbon. So the first thing I want you to notice is that for most of those coastal ecosystems, the amount of carbon stored in the system is much greater than that stored in a hectare of tropical forest. The other thing that's really important to note is that the majority of that carbon stored in coastal ecosystems is in the soil, whereas in the tropical forest, most of it's in the biomass, it's in the green part of the bar. And so we actually don't see most of the carbon that is stored in these coastal ecosystems. And I actually think that's one of the reasons why coastal ecosystems are just now becoming part of the climate mitigation discussions. We don't see the carbon in the same way we do in the forested systems where it's in the trees. The other thing to know about the carbon stored in these coastal soils is that it tends to be very old carbon. It's accumulated for hundreds to thousands of years. And that's important because these coastal ecosystems, part of the reason we're so interested in coastal blue carbon is because these coastal ecosystems are some of the most threatened ecosystems on the planet. Global rates of loss tend to range between 0.7 and 7% annually for these ecosystems. And when we lose these ecosystems, when they become degraded or destroyed, these impressive natural sinks become very significant anthropogenic sources of additional carbon into the atmosphere, exacerbating climate change. So one study suggests that coastal carbon emissions are between 3 and 19% of those of deforestation annually. I have seen numbers that are higher than that. There's a lot of variability there because we're still trying to get a really good scientific estimate of what those losses are. But basically, based on this information, part of my work at NOAA is to look at what are the opportunities for leveraging these blue carbon services in either climate mitigation or adaptation frameworks or in coastal conservation policies. And so one of the first analyses that I had a chance to work on with several colleagues was to actually examine where in U.S. policies, in U.S. federal policies, would coastal carbon potentially fit in. So along with several colleagues, we examined policies such as the Clean Water Act, the Natural Resources Damage Assessment Process, the Coastal Zone Management Act, and the National Environmental Policy Act. And basically we were asking, do we currently implement these policies keeping carbon services of ecosystems in mind? And if we don't, could we? And what would that look like? And what we basically determined was that currently carbon services are not typically included when we implement these policies, but that if we did incorporate carbon services, this actually could lead to a great deal more habitat conservation and climate mitigation. And I want to give you an example of what I mean by that. So when we have a Clean Water Act project, and it's going to affect a wetland, so for example, we might be building a bridge or a road that's going to go through a wetland, an assessment of the impacts to that wetland is performed, and then we determine some kind of a mitigation ratio. So if 1 hectare of wetland is going to be impacted, we then determine maybe we need 3 or 5 hectares of wetlands to be able to compensate for those lost services. The issue is that we tend to do that assessment based on living resources. So we tend to look at the biomass or the number of stems of a particular plant that are going to be impacted. We look at things like bird nests or turtle nests that might be impacted, for example. We don't typically include the soil component. And based on the data I showed you before, suggesting that these coastal wetlands store significant amounts of carbon below ground, providing a carbon service that's very important. The fact that we don't consider those carbon services suggests that we're really underestimating the benefits being provided by those coastal wetlands. So that if we were to incorporate that, you might see that mitigation ratios needed to be something more like 20-to-1 or 50-to-1. So again, this could lead to differences in the outcome of policies, possibly more conservation if we were to consider carbon services when we implement these kinds of policies. Now, a couple of us at NOAA have worked to basically take this hypothetical analysis that we did and try to actually implement it. And so we have 2 examples of where we've been successful in that. There was a Sears Point NEPA environmental assessment that needed to be done for a restoration project out in the San Francisco Bay Area at Sears Point. And we incorporated language into that that discussed the climate benefits of doing restoration. And then, as we were working on that with folks here in the Restoration Center at NOAA, folks in the Restoration Center said, you know what, we're redoing our programmatic environmental impact statement, which is the document that guides all of NOAA's Restoration Center work in doing restoration. And they said we should build in language about thinking about climate services, basically those carbon benefits, into that document. And so both of those documents actually have now gone through public comment and review and have been finalized. And I'm very pleased to say that they do include that language about the importance of considering carbon benefits when doing these kinds of projects. We recognize fully in those documents that every project isn't necessarily going to be a carbon sink, but we wanted to make sure that it was part of the thinking when doing these kinds of project design and review processes. So that's very exciting. Those two pilots have been successful. What about other U.S. policy opportunities? Well, when it comes to federal interest, this actually has had growing interest over the past couple of years with President Obama's interest in climate change and climate mitigation. And last fall in October, the White House released the Priority Agenda for Enhancing the Climate Resilience of America's Natural Resources. And I don't expect you to be able to read all the text on here, but this is from the executive summary from the document. And the second point says, manage and enhance U.S. carbon sinks. So I want to point out that when this document was first being created, they actually weren't talking about including any language about natural carbon sinks. And it was through discussions with NOAA and other agencies that this even came to be part of the document. But then the second part I'm even more excited about is if you read the fine print, which may be hard for you, it says conserve and restore soils, forests, grasslands, wetlands, and coastal areas that store carbon. This was a second really big win where many of us from different agencies, but including my colleagues and I from NOAA, worked to say it isn't just forests that are natural carbon sinks, and these wetlands and coastal areas are really important to have as part of this too. So this is a big win in terms of shifting the way the federal government was thinking about natural carbon sinks and thinking about climate resilience and natural resources. And I'm really excited there were two specific activities, action items in this priority agenda related to coastal blue carbon, and I'm going to come back to one of those in just a minute. So then thinking a little bit more about international opportunities, there's also the setting for the IPCC 2013 Wetlands Supplement. So previous greenhouse guidance from 2006 didn't really explicitly include wetlands, and it definitely didn't include soils, which, as we know, are a big part of wetlands, particularly in terms of climate implications. So the 2013 Wetlands Supplement provides parties, and here we mean countries, with guidance on how to include emissions from wetlands in their inventories. Now, I will note this is not a requirement that countries need to be following this guidance yet. Parties that are encouraged to gain experience implementing the guidelines and report back to the UNFCCC by 2017 on how that's going. But this is a really great step forward in terms of the hope is that blue carbon ecosystems, these coastal ecosystems, will hopefully now be included in future inventories. And it's really great that the U.S. is actually working very hard right now to do this. So this was one of our White House priority agenda actions, which was to improve understanding of carbon storage and cycling in coastal ecosystems, which has led to a baseline assessment of what we know about carbon in coastal wetlands in the U.S. And NOAA is partnering with Restore America's Estuaries to basically work to get wetlands included into our national greenhouse gas inventory by 2017. We had our first meeting of the subset of folks working on this in July, and we're working on a white paper, and then the first estimates for the inventory numbers to be included in the full U.S. inventory should be done by next fall in order to be included in our inventory by 2017. So that's really exciting. We are not the only nation doing this. We know there are several others, including Mexico and I think Indonesia. But we are one of the first to be doing this, and again, we are getting experience using this guidelines that we will be able to then provide comments back to the UNFCCC on how this is working. So that's very exciting. Now, I want to wrap up by talking about some of the other opportunities that aren't U.S. federal or international policies, and here I want to give a regional example out of California that I get really excited about. So in 2006, California passed their Global Warming Solutions Act, or Assembly Bill 32. And this basically proposed that California wanted to, by 2020, be able to go back to 1990 levels of emissions of greenhouse gases. Now, California proposed using a variety of approaches, including policies, regulation, and market approaches to achieve this goal. And as a result of the legislation, they began a cap-and-trade program in 2012, and they allowed those that needed to be monitoring their emissions to offset 8% of their compliance requirements using offsets. And the current offsets include things like forestry, dairy digesters, and destruction of ozone-depleting substances. The proceeds from that cap-and-trade program go into their greenhouse gas reduction fund. And what I get super excited about is that in this spring, 2015, California chose to fund 12 projects in wetland and montane environments, and it included 4 coastal wetland projects, including one at Elkhorn Slough, which is pictured. And so this is a really innovative way to still be getting to that goal of coastal restoration, but with climate mitigation benefits, even though at the moment wetlands aren't part of their current offset protocol. It might be that if these first initial projects can demonstrate really good climate benefits, that wetlands could be incorporated as an offset in the future. But either way, this is a very innovative way to be funding coastal restoration projects. All right, and so then the other thing I wanted to mention is that there are opportunities that aren't based on compliance markets. There are voluntary market opportunities related to carbon and wetlands. And NOAA has partnered with Restore America's Estuaries to identify several of these voluntary carbon market opportunities. The first thing we really worked on was to develop a VCS, or Verified Carbon Standard methodology, to make restoration projects eligible for carbon credits. And so this is a methodology which should be approved sometime this fall, basically any day. I'm hoping to hear that this will be approved. It's gone through the 2 phases of review that are needed for VCS. They have very high levels of review for their methodologies. This will mean that any restoration project anywhere in the world, in any kind of wetland, including seagrasses, can follow this methodology and apply for carbon credits to support that restoration. So that's incredibly exciting. The other thing that NOAA has helped support with working with Ray is 2 landscape assessments of the restoration potential for estuaries. So the first was a study in the Snohomish Estuary, which found that full watershed restoration could lead to the sequestration of 8.4 million tons of CO2. This is about, and that's over a 100-year time frame. So this is about 1 year's worth of emissions from 1.6 million passenger cars. This was the very first study of its kind and really put into context the fact that coastal restoration could really have these impressive climate mitigation benefits as well as all the other co-benefits that come from restoration. And right now, Ray is in the process of wrapping up a second assessment in Tampa Bay, which should be completed this fall. And Tampa Bay is an exciting case study because they have mangrove, salt marsh, and seagrasses in that area. So we'll have all 3 ecosystems included. And will, again, give us a really good perspective on what are the climate benefits of doing restoration, which is very helpful when discussing the benefits of restoration broadly with anyone from the general public to Congress, et cetera. So I want to wrap up then this section by basically making it clear that all of these kinds of policy opportunities have to be supported by really fundamental key science. And so when it comes to blue carbon research, some of the key gaps we still need filled are that we need better regionally specific estimates of carbon sequestration, storage, and emissions from all 3 ecosystems. And interestingly enough, and this makes some sense, seagrass being below the water is harder to map than the other ecosystems. We're developing remote sensing methods of doing this, but it's still very hard given some of the seagrasses are fairly deep, and it's hard to use remote sensing. So we still need better maps of seagrass extent and condition, and in many parts of the world, we actually do not have good salt marsh data either. And then this is a really important one. So ecologists tend to really like to study natural systems. We don't like to go into the degraded ones as much, which I totally understand. That's something we all have a preference for. The problem is that when we come to these policy situations, we really need to understand what's happening in a natural system and what's happening in the degraded systems or the restored systems, so that we can do things like appropriately develop those mitigation ratios that I mentioned earlier. So we really need more data on emissions from degraded coastal ecosystems And this includes the fate of carbon in drowned wetlands, so wetlands that are succumbing to sea level rise or subsidence, etc. So with that, I'd like to move on to the second phase of my talk, looking at green infrastructure. And here I feel as if Hurricane Sandy, to some degree Hurricane Katrina, but then also really with Hurricane Sandy, is a turning point where particularly at the federal level, we're seeing real potential changes in the conversation on coastal resilience and the role of green or natural infrastructure in that coastal resilience. And so here you see from the Hurricane Sandy Task Force rebuilding strategy, highlighted at the bottom is one of the goals that said, consider natural green infrastructure as a coastal hazard mitigation and stormwater management measure. So this is a huge step forward because, as many of you know, when most people think about coastal protection, we tend to think immediately about the bottom row here with seawalls and riprap and levees and dikes. And those are our tried and true engineered structures that do help provide some coastal protection, but they also have some negative consequences, particularly for habitats and diversity. So the fact that now we can place on an equal footing some of these other opportunities in the discussions about whether salt marsh or coral or oyster reefs or mangroves or beaches and dunes and barrier islands, those can also be discussed as part of the importance of developing coastal resilience. But when this conversation started happening about 2 years ago, my leadership at NOAA turned to me and said, well, I want to be able to talk about this, but how do we know what we can really say that natural infrastructure can do? And so that led to a massive literature review trying to understand what can we really say about the storm and erosion protection that these ecosystems provide. And so this paper came out this year, and we determined that factors that impact the amount of coastal protection benefits include things like the depth and crest height for reefs, the vegetation density and stiffness and the plant biomass for vegetated ecosystems. The ecosystem area and continuity of the ecosystem also matters. So separated by open water can make it harder to provide as much storm protection benefit. That said, even narrow bands of wetlands or coral reefs can significantly reduce wave heights. So when we're thinking about natural infrastructure, you might think of this. A community could actually stack different kinds of natural infrastructure. They could try to restore a barrier island and possibly at the same time restore oyster beds or salt marsh so that you're stacking multiple different levels of natural infrastructure protection. And there are many benefits of natural infrastructure. For example, natural infrastructure can strengthen with time. In fact, if you're restoring a system, its weakest day is probably the day you walk away and you say, we're done with our restoration. Now the system has to have a chance to establish. That's the weakest day. Whereas for built infrastructure, the day you walk away having built it is its strongest day, and it continues to then age and slowly lose structural integrity as time passes. So there's a difference, and a real benefit of natural infrastructure is these systems can strengthen with time. They can be self-maintaining, and they have the potential for self-repair after storms, which is not true of any built infrastructure. These ecosystems can also grow and keep pace with sea level rise in many cases. And they can, in some cases, be more cost-effective. And then the one that I think is really important to note is that these green infrastructure opportunities provide benefits at all times to coastal communities. They provide things like habitat and water quality improvement and recreational opportunities, carbon sequestration and storage in some cases. Whereas built infrastructure only provides you storm protection benefit when a storm is approaching. Now, as we were doing our research on natural infrastructure, before I go into the hybrid infrastructure, I want to talk a little bit more about some of the data we're finding, because there are some really exciting, brand new studies out. So in 2014, this really neat paper came out by Mahler et al. Looking at how do salt marshes actually reduce wave reduction. And what they determined was that up to 60% of wave reduction was actually attributed to the vegetation, and that the marsh substrate remained stable even once waves had broken the stems. And so they concluded that the effectiveness of the storm wave dissipation and the resilience of the tidal marshes, even under extreme conditions, suggests that salt marsh can be a valuable component of coastal protection. This was really exciting. Very exciting work done in a flume chamber. Also, in terms of the cost effectiveness, there was a recent study looking at coral reef restoration that suggested that reef restoration might cost something like $1,300 per meter, whereas in the tropics, a breakwater often costs closer to $20,000 per meter to build. So again, this is somewhat dependent on the type of restoration you might be needing to do, but restoration can really be a cost-effective alternative to some of our built infrastructure opportunities. So the other thing I mentioned was the co-benefits piece. And again, these natural ecosystems, natural infrastructure opportunities provide a multitude of additional benefits, and they provide them at all times of the year. So that needs to be factored into our decision-making process when we're thinking about coastal resilience. Now, the other thing that my colleagues and I discovered as we were doing the research trying to better understand natural infrastructure was that there's some really neat stuff happening with hybrid approaches where you might combine some green restoration, green infrastructure restoration with perhaps a seawall with an operable floodgate or some other built structure to provide some additional benefits when a storm is approaching. And so the neat thing about hybrid infrastructure is it combines the strengths of green and gray. And you could even consider using gray infrastructure to protect green infrastructure as it's getting established. And so really there's opportunities to provide more benefits when we combine these two approaches, particularly in places where land is limited and we can't just go and restore acres and acres of wetland because we don't have that land anymore. And just to show you that the hybrid approach is really serious and is actually happening right in front of our eyes, I wanted to show you a couple of examples of what I mean by hybrid approaches. So after Hurricane Sandy, the New York, New Jersey area ran a contest called Rebuild by Design. And this was one of the 6 projects that won. It's called the Big U. And it's called a Big U because if you look at the bottom image, there is a big green U that kind of runs around Manhattan. On the 2 sides where there's not a lot of room, those will be operable flood walls that will come up as a storm approaches. But down in the tip here where Battery Park is, they have designed a whole park area, which if you look at the top picture, will be really used for recreation and outdoor opportunities for people down in the Manhattan area during any time that it's not going to be a storm. And then if a storm approaches, that's all infrastructure that could flood and protect downtown without being damaged greatly. So the hybrid approach really is happening. This project happened to be funded by a combination of HUD funds, Housing and Urban Development funds, as well as foundation funds from Rockefeller and others. But it's very exciting, and they're in the process of trying to begin implementing this. Another example of hybrid infrastructure are living shorelines. Living shorelines use a combination of habitat creation or restoration, and then often some kind of built component to provide protection from erosion and storms. And this provides many of the benefits of natural habitat. The project you're seeing here is an example of a marsh with an oyster sill instead of a granite sill or seawall, but you could use a granite sill or seawall if you needed to. And this is a project at Hivers Island in Beaufort, North Carolina, which is at a NOAA facility. So again, same as with blue carbon, to support these kinds of policy opportunities where there's growing interest in this, there are research needs that this particular community in SWS may be able to help answer. So for example, with green and hybrid infrastructure, we need to know how much protection is provided by different natural or hybrid options and under different situations. So for example, how much does the type of storm and the surrounding landscape features impact the level of protection, or possibly also the time of year, the season. We also need data in particular on just how hybrid systems perform during a storm, because many of these hybrid opportunities have come into place fairly recently, and we don't have a great deal of data on how they function for storm protection. We also need multidisciplinary efforts, and here I'm talking about engineers and ecologists and coastal planners and managers, et cetera, to develop best practices for restoring and building natural and hybrid features. Because this is fairly new for the coastal management community. And in order to try to develop more of these projects, we need more expertise, and we need best practices, basically. So there are some additional research capacity and policy needs that we identified in our paper as well. We need more data on the value of storm and erosion protection benefits, so monetization where possible, in order to be able to compare to our gray alternatives where we have good data. We need more info on the value of the co-benefits of natural and hybrid infrastructure. And this is so that we can do a more complete cost-benefit analysis, and communities can really do a better job of assessing, do they want a more traditional gray approach, or do they want to invest in a greener or hybrid approach. We also need more people with expertise in designing and implementing natural and hybrid infrastructure, and then we need to work to facilitate the permitting process for these options. It tends to be much easier. In fact, you can often get a permit for a bulkhead or a seawall in about 24 hours, whereas natural and hybrid options can take a much longer time. I'm happy to report, however, that several states are moving forward on this. Virginia just passed a living shoreline general permit effective as of September 1, and they're writing a second one for a different kind of living shorelines general permit. So states are moving ahead on this. There are some great examples out there if that's something that a state you're in is interested in thinking about. And there's definitely progress happening here, which is very exciting. Okay, and then I want to get to my last part of my talk, which is looking at nature and biodiversity and human health. So there are prior reasons that have been put forward to conserve biodiversity, which I'm sure you're all familiar with. These include things like the intrinsic value of biodiversity, but also the provisioning of ecosystem services, so things like the production of food or the discovery of new medicines or climate and other system regulation. And all of those are very important reasons to preserve biodiversity. But there's a new reason as well, because new evidence suggests that there are additional reasons to be preserving biodiversity and that there are important connections to human health and well-being. And in my mind, I see human health as really being that ultimate ecosystem service. And so here, I want to be clear, I'm defining human health and well-being fairly broadly. So it's a state of physical, mental, and social well-being. It's not merely the absence of disease. And this is how the World Health Organization defines human health and well-being. And I'm also including in that health and well-being a supportive environment, personal security, freedom of choice and social relationships, adequate employment and educational opportunities, and cultural identity. So this is a very broad view of what we mean by human health and well-being. And so some colleagues and I set out to answer 3 questions related to this topic. First was, is there convincing evidence that experiencing more natural settings, even briefly or vicariously, can improve psychological and or physical health? The second was, does exposure to biodiverse nature result in measurable health responses? And the third was, can biodiversity provide humans and animals protection from allergic and inflammatory diseases? So in answering that first question, we determined that there were a range of positive health responses to environments that are more natural. So for example, natural environments can help reduce stress and reduce blood pressure. Experiencing a natural environment when you're recovering from surgery can make your recovery faster. Doing exercise in natural environments improves mood, self-esteem, energy, and pleasure, and it also decreases the prevalence of conditions like asthma and anxiety. So that was great, and there's quite a bit of studies looking just at that broad nature and human health relationship, but we wanted to really ask the question about how much does the type of nature you're experiencing matter? How much does biodiversity matter? And here we found that there is quite limited but growing evidence that it's not just exposure to nature that may matter, but contact with diverse natural habitats and with different species has important positive impacts for human health. So for example, a study by Fuller et al. Determined that reflection and sense of identity and sense of place increased with plant and bird diversity at a park. Another study by Cracknell et al. Determined that there were greater decreases in heart rate and more improvement in mood as fish diversity increased at an aquarium where they were viewing fish in a large exhibit. And finally, there's a preference for outdoor activity in biodiverse environments that have been reported. So although the results are still limited when you try to search for this topic, the results are also tantalizing in the sense that there's clearly more to be done here in trying to delve into this relationship. But the initial studies suggest that there is a relationship between biodiversity specifically and human health. So then getting to that third question, looking at chronic diseases in biodiversity, previously in the medical field, allergy was considered a response to exposure to too much bad stuff. This is why we have, a prevalence of antibacterial soaps and lotions and potions. And this comes from the idea that it was bad to be exposed to this stuff. But more recently, the medical community is rethinking this, and they're thinking that allergy actually results oftentimes from a lack of exposure to microbes, which leads to hyper-responsiveness to bioparticles. And so a microbe-rich environment may actually confer health benefits, especially to children. And so this is known as the biodiversity or hygiene hypothesis, where the idea is that because of a loss of macrodiversity, because of the habitat loss around the world, and the moving of humans into these urban environments where they do not experience as much of that natural macrodiversity, this leads to a loss of microdiversity that we're experiencing, which actually leads to changes in the human microbiota and results in a variety of disorders. I'm not going to go into a lot of details on this today, but I wanted to share one example I found particularly interesting. This was a study done in Finland on adolescents. They looked at the land use types that were within 3 kilometers of the radius of the homes of these adolescents, assuming that they spent a fair amount of their time at home. And what they found was that kids with allergies had lower environment diversity, and they had fewer kinds of gram-negative gamma proteobacteria on their skin. And so what this suggested was that the loss of contact with the diverse natural world is actually potentially making us sick, because we're losing the bacteria and microbes that actually help to make us healthy and help to make our immune systems function correctly. So I want to conclude again here, though. This field is clearly just opening up, and there are tons of interesting research needs here. So first of all, we really need to better understand the specific mechanisms why and how biodiversity can affect human health. And this means we actually need best ways to measure biodiversity to determine human exposure when we are experiencing different types of biodiversity in nature. We also need to better understand which metrics of health would be the best indicators of biodiversity human health impacts. What should we be measuring in ourselves, and what should we be measuring in the natural world to try to really get at these relationships the best? We need to better monitor biodiversity and integrate this info into public health and natural resource management and policy. There's also a huge need for these large community-wide health data sets, and particularly any that span longer periods of time. Europe is much better about collecting and making available these kinds of data. This is kind of hard to do in the US, but if we work towards this for particular research purposes, hopefully we can start gathering these larger data sets that can be really effective at helping to answer these kinds of questions. That Finland study was only possible because of the countrywide data that they had available. The other thing we noticed in doing this work is that there was a huge paucity of biodiversity and human health work done in aquatic, coastal, and wetland ecosystems. Basically none of the studies, except for that one I mentioned about the aquarium, was done in an aquatic, coastal, or wetland system. So calling all wetland scientists, here's a need to help try to fill in what are the health benefits of exposure to and experiencing wetland ecosystems. And so basically, I just want to make sure the slide advances here. Here we go. So in terms of science to inform policy and planning, in the 19th century, the conditions in urban environments were so bad that this finally led to more of our understanding and our targeting of the way we manage water and sewer issues in large cities. And I think we're at another turning point where we are starting to really understand the way the natural environment impacts and has positive benefits for human health and well-being. And so really we want to, if we place human health and well-being as a central part of urban planning, then we need to start incorporating our understanding of how green infrastructure, natural habitats really affect human health and well-being. And I'm very excited that there are opportunities like the World Health Organization's Healthy Cities and Healthy Urban Planning initiatives, and there's a UK Healthy Cities initiative. There are places where this is starting to happen, and we have models of what this can look like, which is very exciting, that we're taking that body of knowledge and starting to translate it into policy opportunities. So the take-homes here are that biodiversity may actually have direct positive impacts on human health, but more research needs to be done on this. And there's a potential to implement these findings to enhance both human well-being and to develop increased public support for biodiversity conservation and for restoration of ecosystems. And so in conclusion today, I just basically want to say that I think now is an incredibly exciting time. There are lots of opportunities where we can capitalize on the policy interest in topics like blue carbon, green infrastructure, human health, in order to protect and restore more wetlands and to plan healthier and more resilient human communities. And we as scientists should just keep our eyes out for where does our science actually fit in to support these goals, because none of these policy opportunities are going to be able to move forward without good policy relevant science at their foundation. So this is an ongoing opportunity for all of us. And with that, I am more than happy to take questions now. I'm also happy to take questions later by email, and you can check out my website for more information. If you want any of the publications I mentioned and you're having trouble finding them, just shoot me an email and I will share them with you. And I thank you all for participating today.
All right, thank you, Dr. Sutton-Greer, for that really engaging and thought-provoking presentation. I mean, it's a perfect way to start the dialogue on these topics. And if you're ready, I'm going to open up the question and answer period of our session. Again, if you'd like to ask a question as a participant, please type it in the questions box. And I'll read the questions to Ariana in the order that they were submitted. So we do already have a couple of them, and I have a few I want to throw in there myself. One of the questions we have, it kind of dovetails with one that I wrote down while we were talking. It says, is blue carbon limited to coastal or marine systems, or does it also apply to freshwater systems as well? And I was curious that if it does, how does it compare in the carbon storage that you showed where you have the forested systems versus the coastal ecosystems?
Yeah, so that's actually a question that I very commonly get. We've got a listener who's channeling all of my Fish and Wildlife Service colleagues, because that question comes up frequently when I talk about coastal blue carbon with interagency folks. So the answer is that blue carbon really the way it's sort of been defined at the at the broad scientific community level is the carbon sequestered and stored by oceans and coasts. Now, obviously, so we're not talking about inland carbon, but obviously coastal systems, there are ocean water. Then you get sulfate reduction that occurs in these ecosystems. And major methane production. Freshwater system, you have to be, for the saline systems, it really is a little bit more complicated than just the carbon in the soils, the carbon being taken up by the plants. If you're going to apply for a credit, for example, through the voluntary market, you have to actually be able to demonstrate that your greenhouse gas balance is a positive, that you should be getting credits, and that whatever's being taken up and stored in the wetland is not offset by other greenhouse gases that are being released, such as methane or N2O. And so the reason for the focus on the saltier systems was the carbon story tends to be a little simpler. There tends to be little to no methane produced. So it's an easier, basically it's an easier story to tell. The measurements are a little bit easier to do. We focused on those saltier systems initially because it felt like if we could, pardon the phrase because I don't really like it, but pave the way using those systems, that then eventually we might actually be able to open up and include other systems as well. And that's exactly what you see happening with the VCS methodology that hopefully will be approved anytime this fall for voluntary carbon market credits. That, again, is for any kind of wetland, and it doesn't have to just be coastal wetlands. It can be any kind of wetland, fresh, salty, whatever. But again, you will have to follow the methodology and demonstrate that you have an actual carbon benefit in your system in order to get those credits. And in some of the freshwater systems, the methane flux out may actually counterbalance any carbon stored in the system such that you would not actually be a carbon sink. So, Kim, do you think that gets at your question too?
Yeah, absolutely. I was just kind of curious where we fell with the freshwater inland wetlands on the scale where you had the forested systems that were inland forested systems. You may not have that information for this data, but I can, certainly email you about that.
Yeah, I don't immediately off the top of my head have some of that. I mean, so over geologic time frame, so long term, some of Scott Bridgem's work and others have really ascertained that all wetlands are basically a carbon sink over that long term. The hard part with some of these policy opportunities is that no one's really interested in was it a sink over the last 1,000 years? People are interested in, if I do this project today, could I get carbon credits for it in the next, say, 5, 10, or 20 years? And that's where it gets more complicated with the freshwater systems. And I think, honestly, Kim, the answer is that it depends on the system and on the reasons for degradation in the first place. If you are a degraded wetland that was farmed and had a whole bunch of nitrogen fertilizer, when you go to first restore that system, there's bound to be a fair amount of N2O produced out of that system, and so initially it may not be much of a greenhouse gas sink. But, you know, if you were a diked wetland, I know there's some work happening in Massachusetts and also in California, and some growing interest in all of the coastal wetlands that have been diked, where you've put in roads or other water retainment, flooding, basically infrastructure, and you've got diked wetlands that used to be brackish or salty and now are fresh. There's actually a great deal of interest in, if we open up those dikes and allow for more tidal flow through those systems, could we get carbon credits, because we should be reducing the amount of methane being produced in those freshwater systems. So it's a very complicated system. Of course, we all know wetlands are complicated, and that's what makes them so exciting and interesting, but it also makes them very challenging then sometimes from a policy perspective. So the answer is probably going to be, you would want to measure it in your system, and if you found that you thought that you were seeing reductions in greenhouse gases, then that would be a perfect candidate for trying to apply for VCS credits or other opportunities like that.
Good. Well, thank you. And I'm going to kind of combine a couple of questions here. We have folks that are asking about, you know, how is the discussion with carbon going related to a wetland offset protocol? And then I think you kind of touched on this. Someone asked also about the effect of filling coastal wetlands, and that was something about what you're talking about, if there's been any research conducted on that and carbon storage, and, you know, what are the results and implications of that? So sort of a policy side of that versus an ecosystem implication side.
Yeah. So in terms of the, I mean, in terms of the filling of wetlands, you know, where we actually drain and fill them, you're bound to have some emissions as soon as you start draining wetlands, because all of that stored carbon in the soil that's been anaerobic, and that's why it's there, that's why it's been stored so effectively, then gets oxidized. And you know, it basically, the atmosphere touches it, it gets oxygen, and it starts to oxidize. So where we have projects in any kind of wetland, but I'm most familiar with coastal wetlands, you are going to have emissions, and that's the kind of thing where we now want to start doing a better job of accounting for that in our national greenhouse gas inventory. Previously, we weren't really accounting for soils in that national greenhouse gas inventory, and so if you did impact a wetland, the only kinds of emissions you'd think about was the loss of sequestration maybe in the vegetation. But we know that in wetlands, that's a much smaller fraction of the carbon than what's in the soil. So the whole idea of that wetland supplement, the 2013 wetland supplement, and the IPCC guidelines to be including wetlands and particularly soils in our national greenhouse gas inventories is to do a better job of accounting for exactly those kinds of projects. And so it's my hope that we are moving towards doing a better job of accounting for that, not just in this country, but all over the world. Now, Kim, sorry, could you just repeat the first part of the question if I didn't get to it?
I think you did, and I think maybe this next question I have, it focuses on the policy, sorry, and some wetland offset protocol that might be considered. But I think if I ask you this next one, it might be something that will lead into that conversation. It says, do you have any recommendations on how to gain private and public support for some of these projects when much of the research to confirm the benefits has yet to be done? Since we're just now at the very forefront of trying to even show the benefits, you know, how can we get buy-in from, you know, public and private agencies?
Right.
Organizations.
Well, so there's a lot of growing interest in the public sector in climate benefits of coastal and actually just habitat restoration in general. Massachusetts is way ahead on this. California is clearly thinking about this. So that there's definitely still, in addition to the federal interest, there's definitely interest that I'm seeing at the state level. And then that said, there are also some great private or private-public partnerships that are developing. Some of the work in the Gulf that's been done by Sarah Mack and with her colleagues, Entergy has been funding some of her work. They're really trying to look at, you know, what could private funding do to help support some of these new developments. Now, all of the stuff that's new, you know, obviously some of it's going to be highly successful, some of it's going to be less successful. So we have to learn. We have to learn by doing. We have to learn by continuing to monitor and evaluate were these projects successful for the mitigation goals we had in mind. or are we more likely just getting the co-benefits of wetland restoration? For me, I can say that in my conversations with people about blue carbon, I target my responses very carefully to whatever audience I'm talking to. And so there are a few audiences where I don't really even talk about blue carbon. I tend to focus on all of the coastal co-benefits. So I might instead talk about the storm and erosion protection benefits, because so many communities are dealing with flooding on a regular basis, and they really want to hear how can they improve, how can they become more resilient, how can they have less flooding, how can maybe ecosystems help them do that. So I definitely target my responses, and in some cases I don't really talk about climate mitigation, but I can still talk about the fact that, oh, and these ecosystems actually store a great deal of carbon in the soils. That's one co-benefit. So this sort of gets at your part about how do we gain public support, how do we gain private support. It's very much about messaging and about figuring out what is this community interested in, what are their major challenges, and how might wetlands be able to help them with some of their challenges. And so again, in some cases I might be talking more about fisheries benefits, or I might be talking about recreation and tourism, or I might be talking about storm and erosion protection. So I never try to shove the blue carbon story down somebody's throat who's actually not interested in climate mitigation. I instead try to sell the importance of wetland conservation, both protection and restoration, using whatever mechanisms I think are going to resonate with that particular audience. And so that's partly why you saw a multifaceted talk today with different approaches and different ideas about how do we connect wetlands to policy opportunities, because I don't think there's ever any one solution or one policy opportunity that's the best or the only one. It may really depend on the community, the audience you're talking to, and the particular opportunity.
Okay, well, we're getting down to the very last minutes, and there's a couple questions I didn't get to, so I hope that those folks that didn't get their questions answered will go ahead and email Ariana at the email address that she provided, and it'll also be in the presentation when you get that tomorrow. So I want to thank you, Ariana, for taking the time out of your busy schedule to make our inaugural SWS webinar series presentation. And also thanks to our audience for attending today's webinar. And we look forward to your participation in these upcoming webinars. Both the October and November webinars will be presented at 1 p.m. Eastern Time. And also, it might be a good idea to keep track of your participation in these webinars. You may be able to use them for your renewal of your professional wetland scientist or your wetland professional and training certifications. And if you're interested in presenting an SWS webinar, or you have a topic of interest that you'd like to see us cover, go ahead and indicate that on your evaluation survey after the conclusion of the webinar. So thank you again, Dr. Ariana Sutton-Greer, and thank everybody for coming to our very first webinar. Have a good day.
Thank you. My pleasure.